Hey guys, welcome to Code Decode. Today in this video, we will be looking into some collections interview questions part 2. This will be more of a trickier ones, easier but trickier. So let's get started. Please do like, share and subscribe to support us and help this video reach to more of the people like you who are preparing for interviews. So how does linked list is implemented in Java? Is it a singly or doubly linked list? So what is the basic underlying data structures for a linked list? So the basic underlying data structures for linked list implementation in Java is a doubly linked list. You have pointers to both previous and next here. When to use array list and when to use linked list. Now to answer such questions, you must know what is the basic underlying data structures for both of them. The underlying data structures for linked list that we have recently seen is a doubly linked list like this, which is having the pointer to next and pointer to previous both. While in case of array list, the underlying data structures are not arrays but dynamic arrays. So what is the specialty of arrays? Arrays can be done with the random access. That is with index based searching you can do. So that is why we can take the advantage of underlying data structure and use that particular collection. So you can use the random access feature of complexity of order of 1 with arrays or dynamic arrays, and hence array list becomes better for search operation. Here in linked list, if you want to search, you have to start from 1 and go on searching till you find your element. So searching is not that easy or index wise possible with linked list, which is possible with array list. So use array list for searching operations. But when you want to add or update or delete, any of these updations are to be done in the any of the data structures. Then for arrays, what you have to do, you have to, if you want to remove something from between, you have to shift all the elements to front. If you want to add anything, you have to add in between and shift every element after that to one position next. So adding or updating anything in arrays is very difficult task and very not so performance efficient. So for that purpose, if you have more of the update operation, you can use linked list. So if I want to add 4 in between, I will point 2 dot next to 4 and 4 dot next to 3 and 3 dot previous to 4 and 4 dot previous to 2. Simple operation, very much easy in order of 1 time complexity. So for searching, arrays are better and hence array list is better. And for updation, since linked list and doubly linked list is better, hence use linked list for update operations. A very important part, difference between hash map, tree map and linked hash map and when to use which. So the very first visual difference between these three is that hash map uses hashing, tree map is sorted and linked hash map is in order insertion. So the very first thing that you can see out of here is the order of elements. In hash map, since hashing is used, your elements or entry objects will be stored randomly in the hash table, which is the underlying data structure for hash map. So order for retrieval and insertion is random in hash map, while the tree map is sorted because it is tree map. So sorted in the natural ordering is used. So natural ordering is usually the ascending order. So tree map is sorted, while the linked hash map is a specialty of maintaining the insertion order because it is using the linked hash map, and linked list has internally preserving the insertion order. Hence, the insertion order is stored in linked hash map. Now, time complexity of search and insert, you know that it is using the hash code. You fetch the hash code, directly go to the bucket and fetch your entry object. So, time complexity of fetching and inserting is order of 1. While in case of tree, you know that insertion and search in a tree is order of log n, and hence tree map is also going to have the insertion and search order complexity of order of log n. And in linked hash map, again, since it is based on hashing, order of insertion is order of 1. Now null keys in hash map, yes, 1 null key is allowed. In linked hash map, 1 null key is allowed, while in tree map no null key is allowed. What happens is internally sorting is done. So what happens internally, comparison is done. So you compare your next coming object with the existing object. If existing object is null, then you're comparing, you will get null pointer exception. Hence tree map does not allow any null keys. Now underlying data structure support. So you know that hash map internally uses hash table to store the data in the form of buckets, and internally when collision happens, then linked list or the tree with Java 8, a new implementation comes with the tree. If the collision happens and a threshold is reached, then the tree is used. So multiple data structures is used by hash map. With the tree map, the basic data structure uses a red-black tree which supports the sorting of elements in ascending order or descending based on the comparator that you have sent. In linked hash map, the data structure supported is again hash table and not the linked list but the doubly linked list here in the linked hash. Next, the key requirement. Since hash map uses the hash code, hence the equals and hash code implementation or overridden is necessity. Similarly, with the linked hash map, equals and hash code is a necessity. But in the tree map, you even have to sort it. And to sort objects, you need a comparator or comparator. So, along with hash code and equals, you also need a comparator also. Usage. Usually, hash map is very fast. You know that the order of search and insertion is order of 1. Hence, for faster retrieval, we can use it. If we want to maintain the insertion order, not just the faster retrieval requirement, but in the order it is required, then use the linked hash map. And not just retrieval, but also in the sorted order you need, then you use tree map. So when sorting is needed, use tree map. When insertion order is needed, linked hash map. When nothing is needed, use hash map. Simple. Now next, what is priority queue? So priority queue is again similar to regular queue or the stack data structure, but it has a special feature called as priority, which is associated with each element that is entering or exiting from the queue. So a simple object with one extra priority associated with it will make the elements of the priority queue. What is the advantage of it? Now in this queue, a higher priority element is served before the lower priority element, irrespective of their insertion order. We know that FIFO is the order of queue, that is first in, first out. But here when the priority is added, so not just the first one gets out, but the one who has higher priority gets out of the queue first. So priority queue is based on the priority heap and the elements get out of the queue based on their priority and not in the insertion order. That's the difference between normal queue and your priority queue. Can you use any class as a map key, as a key of a map? Answer is no, you cannot use just any class as the key of a map. What minimum requirement that is needed for a key is, if it is a custom key, custom object you are using as a key, then you have to override equals and hash code for sure. And you have to follow the rules of equals and hash code. You have a contract that has to be followed with equals and hash code. Else what will happen, if two similar objects give two different hash codes at a different time, then you will end up either getting null, not able to fetch it, or inserting the same element twice in different buckets, which is a problem. Hence, if you have a custom object to be stored in a key, you have to have the equals and hash code overridden, and also all the rules for equals and hash code contract adhered to. Also, if you're not using a field in equals, do not use that in hash code. This is something which is also a best practices when you're following with equals and hash code. So you have to follow equals and hash code for sure with all the best practices to make that particular class a key eligible. And a very important fact, for making any user defined object or custom object as key, you have to make it immutable. Why immutable? If you make it mutable, it will give you different results with a hash code. And if different hash codes are written, again, if you are adding the same object twice, then if the same hash code is given, equals is given, then you will override the existing value. But if it is not immutable, its value is changing, you will end up adding same object twice at a different bucket location. That's why hash code is important with a mutable object. And if you are trying to get an object, if the hash code is different, you will end up at the wrong bucket, and there you will not be able to find your object where actually it was there at a different bucket location. So in both ways, you will be in a problem if hash code is not implemented properly and your object is returning different hash code if it is not immutable. Another advantage of making it immutable is it helps in caching so that you have a better performance. Now you know that it is immutable, your hash code will always remain same. You can cache it, and whenever it is required again, you can fetch the hash code from the cached value. Also, make classes immutable to ensure that the equals and hash code is not changing in future. That is the beauty of immutability. Your hash code and equals will not change. How to make a Java array list read-only. Currently, you can insert, update, delete, do everything using iterator or for each loop with array list. But if I just want to make it read-only, I don't want to make it modifiable, I don't want to do any update, I just want to fetch objects from array list and not to update any of the data in the underlying data structure for the array list. What you can do, you can call collections.unmodifiable collection method. The collections is a utility class having all static methods. This static method is getting called with the class name, and when you do that, the return type of unmodifiable collection is a read-only collection, and you cannot perform any update or modifications through add, remove or set. What you can only do is get, nothing else. So remember, collections is a utility class having all static methods. You can use these methods directly with the class name. So that is why it is static. How to traverse or loop over a map. So it's easy with list, right? You just put a for loop and you iterate over it. The data that is stored in such data structures is just the simple elements that you can iterate and fetch. But in map, you will not get the element directly. You will not the key and value directly. What you will get is an entry object. So in map, internally entry object is stored. When you try to iterate over map, you will not directly get the elements. What you will get is entry object. Now you have to iterate over entry object to fetch your key and values. So traversing or looping is not that straightforward in map, and hence there are multiple ways to do that. You can do it with for each loop with Java 5, or you can use using iterator, or you can use the entry set with for loop and entry set with iterator. So these are two combinations. The for loop combination with key set and for loop combination with entry set, or iterator of key set and iterator of entry set. We'll see all the four here. So I have a map with an integer which is a key and a string which is a value of companies available out there in the market. I've taken four simple examples and added these into the map, and the way to put it in map is dot put method, and this is nothing but an entry object. So what you can do is you can use the key set method of map, and key set method returns you a set. With this return type of set, you can fetch each key of the set and print that key. So one will be printed, but with key, how will you get the value? So map.get is the method to get value by giving a key. So this is how you print using the for loop and key set method of a map. This method iterates over all the keys, and with keys corresponding values can be fetched using the get method. So that's the basic way of using for loop and key set method. Next is iterator with the key set method. So again, what you can do is you can fetch a set of keys using the key set method like you were doing here. Similar to this also, you can fetch the set of keys, and then on that set you can use the iterator. You cannot directly use iterator over a map because map is not a collection, it's a key value pair. You cannot use iterator directly over the map. You can either use it on a key set or an entry set. So on set, we have initiated the iterator, and it has given me an iterator of integers because it is going to iterate over keys. Keys is integer. So while it has next elements, the iterator has next element, please fetch the next element and print the key and get the value by using the get method of the map. So you can use key set with iterator combination, and using a while loop you can fetch while check whether it has next, and if it has next, then please fetch the next. So has next and next method of iterator is used in the while loop to fetch elements. The third way is to use the entry set with for loop. So it's a combination. Now if we had used for and key set, now we will use entry set in for loop. So what we will do, entry set is going to return you a set, but set is not going to be about the direct values but the entry object. So it is going to be a set of entry object, and when you have an entry object with a key and a value, what you can do is entry.get key, entry.get value. You don't have to use the get method by giving the key and fetching the value. No, entry object directly has a key and a value, and hence it is better to use the entry set to iterate over a map, because directly with .entry set you can get a set of entry objects and iterate over each entry object using the for loop and directly get a key and a value directly from the entry object. And the last way, to use entry set and the iterator on that entry set, because iterator you can use in set. With entry set you will get a set only. On that set you can use the iterator, and with iterator, while the entry objects are there, you can check it has next. When it has next, fetch the next element, which is nothing but an entry object, and fetch the key and the value. So four simple techniques: key set and for loop, key set and iterator, entry set and for loop, entry set and iterator. Simple. Next, let's move forward. How to remove duplicate elements from an array list. So you know that array list contains duplicate elements, but which collection does not contain a duplicate elements? That is set. So there are two ways to remove duplicate elements from array list. First is to use the hash set. But you know that hash set uses hashing. Hashing uses hash code, and because it has no insertion order preserved, you will end up juggling up the elements of array list in the set. So if you try to copy the elements from array list to hash set, you will be able to remove duplicates, but you will end up losing your insertion order. So rather than that, to preserve the insertion order, you already have an existing collection, that is linked hash set. It maintains your insertion order while removing duplicates. So the best way to remove duplicates from array list is not just set or hash set, but a linked hash set, because array list maintains insertion order. You need insertion order, you have to use linked hash set. So what are the steps to do that? Copy all elements from array list to linked hash set. What will happen? Your duplicates will be removed, your insertion order will be preserved, and linked hash set has the elements which was there in the array list in the same order, but duplicates removed. The second, what you have to do is to empty all the elements of the array list using the clear method. So you will end up having the empty array list now. Now the next thing you have to do is to copy all elements from linked hash set to array list, so that insertion order is also maintained and duplicates are also removed. So first, array list to linked hash set, clear the array list from linked hash set to array list. There are multiple ways to do that. More efficient solutions are always welcome in the comment section. We'll move ahead. What is weak hash map and how is it different from a hash map? Weak hash map is again a hash map with the keys that are of weak reference type. Now weak reference is a Java class. If you can see, weak reference is a Java class here. And weak hash map internally uses weak reference as a class to store their keys. Let's see the three type of references first. We have three type of references: strong reference, soft reference, and weak reference. What we are considering here is a weak reference, but to understand this, let's first understand strong and soft references. The strong references is like this: integer a equals to 1. So a is having a value of 1. So any object which has a strong reference pointing to it is not eligible for garbage collection. The reference a is pointing to a value 1, and this is not eligible for garbage collection because the reference has a value right now. Second is a soft reference. An object has a soft reference pointing to it. It won't be garbage collector until JVM absolutely needs the memory. Now I have an integer a equals to 1. I have created a soft reference of a, and now I have pointed a to null. So what happened is a had a strong reference. Now what we have done, we have used a to wrap with a soft reference. Now after making the strong reference a to null, object is eligible for garbage collection, but since it is having a soft reference here, it will be garbage collected only when JVM absolutely needs the memory, else it will not be garbage collected like the strong reference. Now next is the weak reference. The objects are referenced by weak reference. So here we have soft reference. Similarly, we have weak reference here. So integer a equals to 1. We have wrapped with the soft or the weak reference and we are making it null. So what will happen? With the weak references, the garbage collector is eager to garbage collect it since it is a weak reference. So garbage collector will not wait, do I need a memory or am I out of memory? It will not wait for that. As soon as your reference is pointed to null, it will be garbage collector for sure. So these are the three type of references we have. Now with weak hash map, the keys or the entries are stored with the weak references. What does that mean? As soon as your key is pointing to null, even though your entry object is having reference to key, but your key is pointing to null, entry object will be removed from weak hash map. So an entry will automatically be removed when the key is no longer in use, which means that if no single reference is pointing to the key is eligible for garbage collection. Even though you have entry object associated with key, still garbage collector will garbage collect the key. So when garbage collection process discards the key, its entry is removed from the map, even though it is associated with the weak hash map. So garbage collector is dominant over the weak hash map. What happens in hash map really? Even if key is not having any reference or it is eligible for garbage collection, it is pointing to null. Still, it knows that it is associated with an entry object and entry object is associated with hash map. Hence, neither the entry object will be removed nor the key will be garbage collected. Hence, hash map has a dominance over the garbage collector, saying I have the key with me, even it doesn't have any reference, it has a reference with my entry object, I will not let you garbage collect it. But with a weak hash map, it says, okay, since key is not being referenced anymore, nobody will be able to use that key. It is of no use. You can take away my key and I will remove the entry object from my weak hash map. So references of a weak reference type is used as a key in the weak hash map. So keys are weak references which will be garbage collector as soon as there is no reference remaining for the key. So what internally it do is weak hash map periodically check keys. Whenever you try to get a key from a weak hash map, it checks. Does it have any reference? If it does not have any reference, then it is the key is garbage collected by garbage collector and the entry object is removed from the weak hash map also. Now the last but the very important point, what are the best practices related to Java collection framework? While working with Java collection frameworks, you should be very sure you know each and every collection in and out. Reason why we are saying this is that if you have a requirement in your project that you have a fixed size of data that you have to work upon, then do not end up with array list. Why? Because it underlying data structure for array list is not arrays, which is not fixed in size. It is dynamic array, which is dynamic in size. Hence, if you end up using array list, you will lose your performance when your task would have been done easily with a fixed size data structure, that is arrays. Why to use array list? So do not try complicating things. You should know each and every collection in and out. And if your project says requirement is only for the fixed size, use arrays over array list. Secondly, if you have to have a key value pair, normal collection cannot use it. You have to use something which is out of the collection hierarchy, which is a map with a key value pair. Client says you have restriction over a map of insertion order. You have to maintain a queue or you have to maintain the order in which the insertion order is done. Then what you have to use? You have to use linked hash map. Hence, knowledge of linked hash map that it maintains the order of insertion is important for you to know before implementing such kind of implementation required by the client. Now, if you don't want to have duplicates, you can use set. So that is how you can, based on your requirement, choose the correct collection based on the need or the requirement of the project. Now, some collection classes also allows you to specify the initial capacity. Now, if you know the initial capacity that yes, I would in future only need 10 elements. So what you can do is you can specify the initial capacity so that you will avoid the resizing. What resizing internally requires is creating a whole new data structure with 1.5 times or twice of its size and copying everything from the old to new, and then old is garbage collected. It is not only wasting your memory, also using your garbage collection cycle, but also reduces your performance of the application. So to prevent such kind of multiple operations of resizing or dynamic movement to the new data structure, you should always try using the initial capacity. So initially only you know that you need 30 elements, and if the initial capacity is initiated with 10, then you would end up creating new data structure twice or thrice, which is bad. Hence, if you know the initial capacity that 30 will be there for sure, then specify that initial capacity with the constructor of that collection only. Try to implement interfaces and not the classes so that you can change the implementation later at any point. For example, use list of integer equals to new array list or list of integer equals to linked list. So implementation can change, but you can always prefer using the interfaces as the point of reference. Then use generic type safety to avoid class cast exceptions at runtime. Usually collection always comes with the generic type only. And very important point, as a key in the map, always use immutable classes to avoid implementation of hash code and equals in the custom class, or to prevent any variations in return value of hash code, so that you can end up at the right bucket during adding and during retrieval of your object from the bucket in the hash map. So always try to use the immutable classes to prevent different hash codes for the same values. So that was all about the best practices with Java collection framework and tricky questions of the interview questions. If you want to know more such experienced level interview questions for the Java collections, please let us know in the comment section. We'll create another part for the Java collections. Since it is such a big topic to cover, it is difficult to cover everything in 1 or 2 parts. Just let us know in the comment section. We'll create another part for you. Thank you.